So the antiderivative of x is x squared over 2. And we can break those up as two separate antiderivatives because of a property we studied with the integral operator. If you're trying to evaluate the integral of two separate terms, then you can find the antiderivative of each term separately. And then I draw this vertical line to show that I still have to plug in the limits of integration after I've found the antiderivative. And then here the antiderivative of cosine is sine, not negative sine. The negative symbol there is coming because it was already built into the expression we were given. And the reason why the antiderivative of cosine is just positive sine and not negative sine is because the derivative of sine is cosine. So the derivative of this makes this. That makes sine of x the antiderivative. Okay, so now all we have to do is plug in the limits of integration. So for this first one, if you plug in pi over 2, then you get pi squared over 4. And that's what happens when you plug pi over 2 in for x squared, and that's being divided by 2. So that's the same thing as multiplying by 1/2. So this is pi squared over 8. Then here, if you plug in pi over 2 in for sine, then sine of pi over 2 is 1, because the y-coordinate on the unit circle at pi over 2 is 1. If you plug in 0, sine of 0 is 0. This is it. It's just fraction work from there. It's pi squared over 8 minus 8 over 8, right? So pi squared minus 8 over 8 is probably the WebAssign answer.